Aloha champions, and welcome back to our second social studies video of this week. There will not be a science video tomorrow because remember, Thursday and Friday are half days for you, so no videos from Mr. Chambers. However, that does not mean that you as a scholar can't be proactive and help us achieve our school-wide WIG and hop onto ExactPath to get 30 minutes of math, 30 minutes of reading, and 30 minutes of language arts each and every week to help us earn those trophies. We're in a new unit of social studies, and in this short unit we're going to be exploring the mountains of our world. And some of this might sound like it should belong more in a science class than in a social studies class, but it's still understanding our world and the geography that makes it up. So, without further ado, we're getting into Unit 2, all about mountains, Chapter 2, Introducing Mountains. Our big question for today, something that we've already been privy to and something that we will hear again in fourth quarter when we go over our geology unit for CKLA, is figuring out how are mountains formed. So if there's anything Mr. Chambers has taught you throughout these videos, it is how mountains are formed. Hopefully you've learned a lot more than that throughout this year, but you will have this information at least 3 times throughout the year. So, introducing mountains. Oh, beautiful, for spacious skies, for amber waves of grain, for purple mountain majesties above the fruited plain. From the song America the Beautiful by Catherine Lee Bates, written in 1893. A song we are all familiar with and have sung a time or two during our morning assemblies. But purple mountains? Well, of course, if they get hit by the right light. We've got mountains such as Denali, one of our largest mountains in Alaska, that is glowing purple here in the afternoon sky. The importance of mountains. Couple vocabulary terms for us to turn our attention to before we learn about the importance of mountains. We have minerals. Minerals are naturally occurring substances found in Earth's crust. The small pieces that form our rocks, whether metamorphic, igneous, or sedimentary. We have a barrier. A barrier is something that blocks movement. And we have weathering, the breaking up of Earth's materials into smaller pieces. All those minerals being either washed away with rain or wind, breaking up those into smaller pieces, the natural weathering that occurs. People have long admired the beauty of mountains. Some people long ago even worshipped the mountains. They placed offerings on mountain slopes in the hope of good crops, good weather, or even good luck. Mountains play a part in many different religions. Moses, for example, received the 10 Commandments on the top of a mountain. The ancient Greeks believed that their gods lived in the mountain or on Mount Olympus. Excuse me. Cut that out. Will I? We'll see. Mountains are important in many ways. They affect Earth's weather and our climate. They provide a home for many animals, and they contain very valuable minerals. Mountains have historically made trade and travel difficult. They have also acted as barriers to keep out or slow down invading armies. More recently, mountains have attracted tourists, skiers, hikers, and climbers, people who want to conquer those mountains. No matter how terrified they are of heights, they still put on their helmet and want to climb a mountain. This guy. So, before we move on, some cool facts about mountains. For a landform to be called a mountain, it must rise at least 1,000 feet, or 300 meters above its surrounding area. So South Mountain has to be at least 1,000 feet tall, taller than the valley that we live in. Some mountains, such as the Himalayan mountains, are still growing. The mountains are still growing, while others, such as the Appalachians, are being worn down by weathering, erosion, and mining. So the Appalachians, the shorter of the two main mountain ranges in the continental U.S., they're shrinking, while other mountains are growing as land masses continue to collide. Their tectonic plates continue to push, and as they continue to push, those mountains get taller and taller and taller. And so while Everest may be the tallest mountain right now, it is possible that in thousands and tens of thousands and hundreds of thousands of years, as those tectonic plates continue to crunch into each other, it is possible that there may be a new tallest mountain, or Everest would just get taller and taller and taller to climb. It's all a matter of time. Maybe you, as a future scientist or historian, will understand that better than Mr. Chambers is explaining. How are those mountains made? Well, let's think to some vocabulary terms we've already heard in a previous science adventure, and we'll hear again in a future CKLA activity, is plates. Plates are large sections of Earth's crust that are able to move. So how are these mountains made? Well, mountains are formed in several different ways. To understand how mountains are formed, you need to remember that Earth has a crusty shell made up of gigantic, humongous plates of crust. These plates can shift, crack, and wrinkle. Folded mountains are created when Earth's crust shifts. As it shifts, one piece of rock folds on top of another. The Himalayas in Asia are folded mountains. Some of the Appalachian mountains in the eastern United States are folded mountains too. So you got the two crusts. They're coming together. And as they crunch into each other, the mountains get taller and taller and taller. Okay? We also have fault block mountains that are created when pieces of rock are driven up. The Sierra Nevadas over in California are fault block mountains. Remember San Jose Fault, where you've got the two pieces of plate shifting next to each other. There's large rocks in there, and when they shake and push, and eventually they'll both shake upwards. Okay? So one will shift up, one will shift down. So the first one, the fold over, one layer of crust folds over the other. The other one, you push, and one goes up, one goes down, creating those mountains. Okay? We also have dome mountains, which are created when melted rock called magma pushes up below the surface of the Earth. As the magma moves up, it makes a bump on Earth's surface. So where you've got those hot spots that we talked about before, it becomes a volcano and it breaches open and that magma erupts into lava, you get a dome mountain. Something where you've just got extra pressure of magma pushing up Earth's crust. Those don't always result in volcanoes. These bumps often look more like hills than mountains. The Black Hills of South Dakota are examples of dome mountains. Another vocabulary, lava. We've seen this word before and we'll see it again. Lava is magma or melted rock that reaches Earth's surface. The volcanic mountains form when a volcano erupts and breaks a hole in Earth's crust. Lava and ash flow down the sides of the volcano and harden into a mountain, and many islands, such as the Hawaiian Islands, are actually the tops of volcanic mountains. Japan's highest mountain, Mount Fuji, is a volcano that last erupted in 1707. Okay, so here's a picture of Mount Fuji. As a volcano, it does steam and smoke from time to time, but it hasn't erupted in over 300 years, which might be good for the people of Japan, but they're still a little cautious. Okay, remember when you made those awesome volcanoes before we went on winter break? Same concept here, just in a historical context of social studies than the scientific explanation of geologists. And that's the wonderful thing about learning, is that something that you learn in one subject carries over into another subject, and all the world is connected, piecing together all the pieces that you've learned so far and will continue to learn to make up this wonderful landscape that is our knowledge. The highest mountain in Africa is Mount Kilimanjaro, and it is an extinct volcano. Extinct, a word you can use to describe volcanoes or certain animals or plants, means that it has died out completely, no longer exists, and will not revive, unless science does something weird that it's not supposed to. But it's extinct, completely dead. Volcanic mountains can be produced by a few days of huge eruptions. However, most mountains take thousands or even millions of years to form. They form so slowly that in real life you can't see them changing at all. Some of Earth's mountains, such as the Appalachians, were formed from more than 200 million years ago. Others, such as the Rocky Mountains in western North America, were formed only about 1 million years ago. And you can often tell whether mountains are young mountains or old mountains by their shape. Young mountains are usually steep. They have very high elevation and are often sharp and pointy. Old mountains have been worn down by many years of erosion. Okay? So if you look at a picture of Mount Everest, you'll notice that there is snow on top of the mountain. Most tall mountains are covered with snow all year long. That's because the farther above sea level you go, the colder it gets. We use the term sea level to explain land elevation in relation to the surface level of the world's oceans. You may have noticed that this if you have ever hiked up a mountain or driven to the top of one. It's colder up top than it is down at the bottom. Maybe not necessarily for South Mountain. You might put on a little hoodie or windbreaker because it's a little windier up there, but not drastically cold. However, heading up to Flagstaff, where you climb all that elevation, while snow doesn't exist on the mountains all year round, it lasts for a longer portion of the year. Okay? Mountaintops are usually cold, even when they are located in hot places. Snow covers the top of Mount Kilimanjaro in the African country of Tanzania all year long, even though it is very close to the equator. So Kilimanjaro, a lot taller, always has snow at the top because of how tall that mountain is, which also indicates how young that mountain is, relatively speaking, in geological terms. All right, couple of vocabulary terms to reflect on. We've heard most of these terms already in social studies or science. But we have elevation, which is the distance above sea level of a spot on Earth's surface. So on Monday, remember you looked at the bird's eye view of the mountain. The purple areas were the tallest parts or the peaks of those mountains with the highest elevation. Erosion is the carrying away of soil and rock by water, ice, or wind. So those Appalachians used to be young, fresh, pointy, sharp mountains, but over time, wind and rain have washed it down, and it's kind of eroded into shorter mountains. The equator, as we talked about in Unit 1, is the imaginary east-west line on a global map that is an equal distance from the North and South Pole, located at 0 degrees latitude. So let's look at some major mountain ranges in the mountains of the world, identified by height. We have Mount Everest, tallest of the tall, over in the Himalayas, in Asia, Nepal, Tibet area, north of India, South China, which stretches 29,000 feet tall, or 8,848 meters. It is the highest in the world. Mount Aconcagua in the Andes, South America, Argentina, is 22,000 and it is the tallest in the Western Hemisphere, both South and North America, including countries such as Argentina and North America. We have the mountain Denali in Alaska, which is 20,320 feet, and it is the tallest mountain in all of North America, whether that's Mexico, United States, or Canada. Mount Kilimanjaro stands on its own. It's not in a range of mountains. It's a big dome. It is 19,340 feet and tallest in Africa. Mount Elbrus in the Caucasus in Russia is at 18,000, the tallest in Europe. Mont Blanc in the Alps, located in Europe, is the tallest mountain in the Alps, a famous mountain range north of Italy, south of France. Surrounds all of Switzerland. Mount Jebel Toubkal, or Topkol, I should say, in the Atlas system is the tallest in North Africa at 13,000. And the tallest mountain in the Urals is Mount Narodanya at 6,214 feet. The tallest peak in Arizona is Mount Humphreys, located real close to Flagstaff, and that is somewhere between the height of Mount Narodanya and Mount Jebel Toubkal, with about 12,000 and change for its total height in feet. Here, if we look at this map, we have identified where some of those mountains are. Tallest in North America is Denali. Tallest in all the Western Hemisphere, including North America and South America, Mount Aconcagua. In Africa, you have Mount Kilimanjaro. In Northern Africa, which is normally a little flatter than there, you have Mount Jebel Toubkal. Mont Blanc is the tallest in the Alps. Mount Elbrus, tallest in all of Europe. Mount Narodanya, tallest in Russia. Mount Everest, tallest in the world. And no tall mountain claims for Australia. Okay, so hopefully you enjoyed your time learning about those mountains. And remember that mountains take a long time to form with those tectonic plates crashing into each other. You've got 5 to 10 questions to answer on Google Classroom. Thank you so much for your time. Stay awesome, and I'll talk to you real soon.